morning, guys. Sorry that I have this absence today, but I wanted to stay a bit on track. So what we're going to do is in this video, I'm going to go over really quickly the example 3 from the lesson we did yesterday, just to clarify what our answer meant. I was like, oh, here's the answer, and then the bell rang. Where did that go? So what I want you to do is I'm doing my subplans kind of quickly, so I'm not able to make this into an ed puzzle. This is just a video with no questions on it. So I'll kind of ask questions as I go, and then you can pause the video when you hear me ask questions and like, okay, let me think about this for a bit. You can talk to each other and be like, hey, are you understanding what she's saying here? Can we talk about it if you're not understanding? But we're going to go over, like I said, just this last question here from yesterday's notes, what it means, and then you will have time for the assignment. So you'll pause the video, you'll work on the assignment, and then whenever you happen to finish the assignment, you're going to come back and watch the rest of the video for the first half of the next lesson, and then I'll finish that up with you tomorrow. So yesterday, we did the math to figure out the expected number, which again, expected value means is interpreted as the mean. It is the average of what you should expect to get. On average, this is how many boys would occur in a 3-kid family. Now the answer was kind of weird to us because we did this math. We multiplied each value point, which was 0 boys, 1 boy, 2 boys, or 3 boys, by its probability from that table that we made. And then we added that all together because that's what this tells us to do. It tells us to add everything together. And we got a mean, because this is our mean, right, of 1.5 boys. And yes, because it's our mean, it has the same units as whatever our variable is, and our variable is number of boys. And you might be saying to yourself, well, you can't have 1.5 boys. However, I'm going to go ahead and write this here. You never round expected value. I know that you cannot have 1.5 kids, but when we talk about expected value, it really literally does mean the average, the mean. And even if you can't have 1.5 boys, it gives us an idea that over a very large rung. So interpret in context. Let's go ahead and add this now to your notes. So in context, what this means is on average, over a, move this here, over a, hey Major, there's Major, over a large amount of families, right? If we looked at a bunch of families that had 3 kids, a ton, what we would find is if we found the average of all the boys that all those families had, on average, over a large amount of families, they expect, because this is expected value, expect to have 1.5 boys. I know that sounds weird, but that should make sense. We know that when you have a kid, you got a boy or a girl, according to just that, right? So that's 50% chance. If you've got 3 kids, half of them should be boys. That's 1.5. So even though it's not logically possible, that is the actual average of how many boys you would be in a family if you had 3 kids. That's what expected value means. What you might expect if we looked at every single infinite number of families with 3 kids. So from here, I want you to go ahead and pause the video. Whenever you're ready to come back, you'll come back. We'll keep going with the notes, and that'll be the last thing you do. So once more, right now, you are going to do the Unit 6, Day 1 assignment. Remember that the answers are in the back of the book. Everything is odd, so I've been doing that just so that you have the answers in the back of the book. You can submit that into Canvas already, and then once you're done, you'll come back and watch the video. If you do not finish the assignment and the video, this video will be your homework, but I'll clarify that in the post as well. Okay, so go ahead and pause the video, and I'll see you back here in a bit. Hi, welcome back. So we're going to go into day 2 here. Like I said, we're only going to do about half of the notes, just to try and keep us on pace as best as possible. And then I'll come back hopefully tomorrow and finish them with you. So yesterday / we just looked at it at the beginning of the video. We got the formula for the center. Remember that centers is mean, median, right? So the center of this distribution is going to be the mean. So just to refresh our memories, take a second to copy that over from your notes, just so you're like, okay, let me write it down. When we write things, we remember them a bit better. Okay, so here is our formula for the mean. It was the summation of, each individual value multiplied by its probability. And that's it. We do that, we add them all together, we get our answer. So now, today we're going to get the formula for the spread, which is the standard deviation, right? Still standard deviation. So in words, again, to interpret what this formula is, the standard deviation is the square root, right? That's what that is there. Of the sum. Once again, we see summation. So we're going to be adding things together. What you're going to be adding together is the product, so multiplying right there, of each value's distance from the mean squared and its probability. This sounds very confusing. Thankfully, often we'll be able to actually plug into our Casio to get standard deviation. Expected value is not that hard to do by hand. You're only multiplying two things together and then adding them together. Standard deviation is kind of a pain. So you will actually be able to do this in Casio. So on the next slide, you guys can work together again on this if you're like, wait, I'm not sure if I'm seeing the right spots. These are the directions for how to plug into your calculator to get the standard deviation, the mean. What you're going to see is once you click one bar, it's going to list out all of these different calculations you could possibly do off this data. X bar is your expected mean. So again, expected value. And this is your standard deviation. So again, you can read through this as you try this next problem. I'm going to give you the answer, and then you can check and make sure that you're getting it right. So once more, refer to this list on your Casio as you do this problem. So we found the mean for this already, and we already did this table, so I'm just going to copy it over here. This was from yesterday. We had 1 out of 8. For 0 boys, 3 out of 8, 3 out of 8, and 1 out of 8. Now, you do need to go ahead and get these as decimals because that's what you're going to be plugging into the calculator. 1 out of 8, just FYI, is 0.1. Oops. I'll leave that for you guys. Get those as decimals and then follow the directions here. Yes. What you're going to end up doing, actually, I'm going to write this out for you guys here. When you go to your list view, you're going to have 2 columns. Yeah. You're going to have like 1, 2, 3. We have 4 values. When it says to assign the outcomes to the frequencies, let me see. Oof. Okay, I think what I'm going to do from here actually, guys, is just link you to a video that shows you how to do this. This is the directions, but I pulled these directions off of a video. So I'm going to actually stop the video right here. You can see I'm doing this kind of on the fly. You'll watch that video and then you'll come back. So you can try this problem by watching that video and then we'll come back.